come and join one of our classes.
Well, you can meet with us on the vacations.
I think maybe only for those that needed it.
We're so smart.
Well.
We do so well.
Probably he looks for the groups and see, oh, okay, this guy needs help.
Yeah.
Okay, so I have my body measurements here. Okay, so we're gonna walk me through this a little bit. I mean, I did the other ones just fine. So I'm going to go to graphs, legacy dialog, scatter plot, simple, define. I'm going to put my x-axis is
the height.
The height.
And this is the part that for me this is the most important thing, is to understand the independent and the dependent variables.
Right, and I wrote it out. I mean, I just like I got that right. I got the x-axis. Oh, the x height should be the x-axis.
Yes.
Okay.
The height is the x.
Okay.
It's the independent. The height don't depend off the weight.
Okay, and I still get this weird scatter plot. It's all bunched up together.
Yeah, but for instance, I did it on SPSS, and on the height, on the x-axis, it starts in 65 and it ends on 77.5.
Well, how do you do that? How do I change that?
I didn't do anything. I just click the same as you.
See, and that's mine starts on 20, and so I've got this big, huge cluster.
Yes, I understand.
I don't know how to change that. So that's where and then everything else wasn't right either. So then after that, I'm going to do analyze, regression, linear. And my dependent is weight.
Michelle, there's 2 body measurements. Did you do body measurements corrected? Because there's body measurements, SAV, and there's body measurements corrected.
Okay, let me try that again then.
Yes, you're right.
I knew it was just something dumb. Okay, weight. My y-axis is the weight. Body. Is it the height?
Let's see for this one. Yeah, the X is the height, the Y is the weight.
Right, but I only see one height.
Okay, let me check.
Yeah, but I think Jessica is talking about the file. Are you using the body measurement corrected file?
Body measurement corrected file. I clicked on the one they gave me.
So probably it's correct.
Let me reopen it. Maybe I opened the wrong one.
The file must be body measurement corrected.
Okay. I'm sure that's probably right. My mistake right there. Avery, can you go make sure Tia's awake after you go to the bathroom? Okay, let's try it again. Sorry, guys.
That's okay.
Oh, it opened up an Excel file.
Yes, but if you take that Excel file and
oh, hold on, what happened?
So you took that, you take that to the SPSS.
So I have to open up SPSS?
Yeah, but you need first to open the software.
Okay.
And then you go to open files on the SPSS and you open the Excel file there.
Okay, I've never done that before, so hold on.
I didn't have to do that. I just went down to the SPSS files and clicked on it.
Well, my SPSS is opening. It's taking a minute.
So I don't think you need to get the Excel file because there's one for SPSS right in the second batch.
Where?
Uh,
Where are you? Look, what do you mean, Jessica? Where are you?
Well, I opened the main file that stores all of the.
Okay.
So you just go all the way down because the top is the Excel files, the bottom is the SPSS files.
Okay.
Well,
Anyway, I could manage that, and I opened the Excel file with SPSS.
Okay.
I figured out how to do it.
You're smart.
Okay, let's try that again. Body measurements corrected.
Yes.
SPSS.
It's
Okay. How did that come open on Excel? I have no idea. Now I don't know what's happening. Sorry.
It's okay.
no problem.
Oh, now it's telling me it can't be opened. Okay, well, I can figure that I just opened the wrong file. So now my computer is not doing anything else. Okay. Are we ready to go on?
Sure.
Yeah, hold on. I can't get it to, like it's frozen. Okay, we're gonna go to that. Okay, so did we understand the rest of the homework? Did you?
There's a couple things I had trouble with. Let's see. Okay, let's see, where is it? I don't know how to tell if the y-intercept is interpretable.
Oh.
Do you know how to?
Yes, it's a you must look for the logic. For instance, in the question 6, you have the y intercept is minus 206.596, correct?
Yes.
And that is because we established that the y-axis is the weight of each man. Okay.
Okay.
So it cannot be negative.
Okay.
We don't have negative weights nor heights. So it's, in this case, it's not interpretable because no man can have
Negative
height, a negative height.
Okay.
Okay.
So hopefully,
So if it's
like that.
if it's negative, generally it's not making sense.
Yeah.
Okay.
And I saw the video and that video that we have there on the explanation part, and it says on the video that normally the y is not interpretable.
Oh.
Okay.
Normally, okay. So and when it's negative, it's always interpretable, not interpretable.
Okay. Okay, because I was having a hard time visualizing that, but now that makes
Mhm.
sense. And then I guess that was the only question I really had. I couldn't get number 16, but I don't know why.
Avery, did you check on Tia?
Michelle, you did 16, right?
Yeah, I got it.
How did you get that?
I just did what we did last time and had my covariance. It was in that data box.
Because
Yes,
I couldn't find it. You mean you did what we did last week?
Yeah.
The Varate thing?
Yeah.
no,
Okay.
we did it this week, correct?
Yeah, this week.
Oh, yeah,
This
I mean
week.
last
This week.
lesson.
Yeah,
Yes. Mhm.
Okay. Okay, so that's good to know. Then I can figure that out. And so everything else I think I'm okay with. It just takes me a long time to sit there and think about it, but I can get it.
I know. I'm the same way.
I'm going to work on this homework, but I only did it. I did until only question 8, no more than that.
Well, it just kind of
Sorry.
repeats itself.
Yeah. If you could do the first part, you could do the end. I just messed up the first part because I didn't get the right thing. So, but once I opened the right thing, I had no problem figuring everything out. Okay, are we ready for the quiz?
Sure.
And why is the homework quiz harder than the group quiz?
I don't know. That's not fair.
Our homework quiz should be a group quiz.
I think our exam should be a group exam.
I know. Y'all to do a group exam.
Okay, so do you want me to start reading question 3?
Yeah, hold on. I'm still trying to open it. Okay.
Okay, so question 3. We have to open. Let's see, I have to open this.
Okay, my internet connection is a little bit better. So I want to do it with the. Let me open.
Okay, just let me know.
VMware. Let me open VMware. We have a
Is he awake?
file.
Okay.
We have a file. The file is the map self efficacy. Okay. Copy. Okay.
Okay, so the y on question 3, the y-intercept is just
2.0.
0.0, right?
Yeah, 2.0.
We have a equation here.
Is that right?
Just a moment, almost there. Okay, so what is the y? It's the 2.0, correct?
Yes, that's what we think.
Okay.
Mm-hmm.
And then the slope is 1.5?
Yes.
Mm-hmm. Correct.
Okay, so for question 5, out,
So
we just times it by
Plug in 16.
16. So I got 1.
0.25 plus 16
Times 16.
Mm-hmm. Yes. Minus 3. 1.
Yeah, that's what I got.
Let me see if I get it, just in case you guys are wrong.
I would never be wrong, Michelle.
I know.
Come on.
I like that confidence. Yay.
Well, I got
False
one
confidence.
too, so we must all be right.
Okay.
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 Yeah. Okay, so be sure to use the confidence data. So confidence data is what?
Okay, so.
Are we on?
Okay, now see they throw 2 new words in here, explanatory variable and response variable.
That is, so the independent is the explanatory. You should put that on your notes because they use them interchangeably. And the dependent variable is also called the response variable.
Mm-hmm. Correct.
Okay, confidence data and then score is
So,
I'm already opening the file.
okay. So we are going to make a scatter plot of the 3 data shapes. These data. Okay. So
Okay, but
making a graph.
okay, but we need to understand gender, score, confidence rating mean.
Okay, so
Shane Golding, another researcher studied
confidence is our.
Confidence is the X.
Okay.
Score is the Y.
Yes.
Yes.
Okay. Okay, make a scatter.
It's confidence and score, correct? So
Yes.
in the y-axis we have the score, and x-axis we have the confidence.
Right.
Correct.
Yes. Correct.
Okay.
So is it a hot dog shape or hamburger shape or banana shape?
Let me see.
Let me see.
It's not a hot dog. It's not a hamburger.
It's a strange question. It's more like a hot dog.
Hot dog, right? Because it's not curved.
Yeah, I think it's a hot dog.
Yeah.
That is the dumbest question.
No, it's not. It's a very strange question. I want a hot dog with ketchup.
Right.
Please.
What if you don't know what a hot dog is?
Yeah, yeah, you're right.
Some countries don't have hot dogs, right?
I'm sure that in Portugal we don't have so many as in America.
Yeah.
Sure about that.
Okay. 7. Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using a simple linear regression to model this data?
Simple linear regression. That's a good one. I don't remember.
I would say the
Yes.
middle one. It's not completely reliable.
No, it's not, because I wouldn't think that would be a 0.530. I would think it would be a little bit stronger. Just by looking how it curves up. It's hard to tell.
I haven't run the numbers yet.
I didn't run the numbers either. I just did the
line.
yes.
How can we say if it is appropriate or not?
I would say it's not reliable.
But yes, but how?
But what do you think?
No, I'm not understanding this one.
So I just remember him saying that we can't always use the scatter plot. It's not always reliable.
Why? What is the conditions? Do you remember?
No.
Okay.
Well, he said himself in the video, if I remember, that it's not the scatter plot's not very reliable. That's why you have to run other tests to go further and see.
Yeah. So I would say not reliable.
You would say
the second one.
Yeah, that's what I have.
Okay. We agree on that? Okay. How many observations are in the data? What does that mean?
Okay, we just have to see how many observations are in the data. Well, we just look at the thing, scroll all the way down and see where it is.
139?
Yeah, 139. That's what I would think.
You looked on the
data view.
On data view, and you scroll down and.
If we run a test, it would tell us that too. If we
Okay.
analyze it really quick, let me do that. We're gonna have to do it anyway. So.
Are you doing a regression?
Yeah.
Linear? Or partial?
Linear.
Linear. So remember for dependent is the score, correct?
The Y is the score.
Yeah. Okay, so our degrees of freedom are 138, but that's not how many observations. Okay, I think it's 139. What do you think?
The y-intercept, let's see.
Yes, it's 139.
Okay.
If you see on the there's a NOVA
Right.
test, and the degrees of freedom is 138, and we know it is
-1.
-1.
Oh. Wait, okay. That's what you do for the y-intercept?
Okay, so are we on the y-intercept?
139. Wait. 1 second. How many observations? Okay, that's what you're talking about. Doing number 8, right?
Yeah, number 8 is 139.
Okay.
And number 9.
Is that
18.69?
Yes.
Yeah.
But we have to put that 0, huh?
Yes.
Because I was going off the scatter plot. It wasn't working out very well. Okay.
Then the slope is 12.695.
Yeah.
So the predicted will be 12.695 plus 4.
So I have to write the equation out. Okay, what'd you get?
69.470.
Okay, so I did it in the SPSS, and I got 69.46935.
Yeah, so it's almost the same. 470. 69.
Yeah,
69.
I got 69.46935.
693.
Six.
It's like 694. I remember to read that they when we do by SPSS will be different from the calculator.
So what answer are they wanting? SPSS or?
Actually, I saw both results when. And
Yeah,
if you go to the solutions of the homework, they have the two answers, calculator and software.
Right.
Yeah,
So
but
I
for
think
question
both are correct.
Huh.
I'm going to put the calculator one.
Okay.
So 69469.
Yeah,
Okay.
that's what I have.
I got on the SPS, which was rounded to what we got on the calculator. So at least it was close.
Yeah.
It's very close.
Okay.
Well, I can run that one, and if it's not right, then we'll go back and do it Ricardo's way.
So number 12. Okay, so what is this asking?
I have no idea.
Confidence.
Because there is a positive correlation, we can use the larger X value to find the larger predicted value of Y.
I mean, do we look at the chart and try to find the largest company?
Okay.
That seems silly.
So we want the largest score or the largest confidence?
The largest confidence score or rating. Okay. Oh my goodness. Let's see.
I've got a 580 here. Do you see anything higher than 580? Oh, there's a 6.
And because the scale is 1 to 6, the maximum must be 6.
Yeah.
That's But the question is, are we now calculating
Okay, so the
with an
largest,
X of 6?
well, it gives us that. The score is 96.7.
96.
Wait, what?
But we could also put that into our equation and see if we get that same thing.
No, you must be higher than the previous one. With X of 6, correct?
Right, so if we do 12.6
Times the
95
slope
times 6
and plus
plus
the Y.
What number are you plugging into that formula?
a 6.
X?
Yeah, but I got 94.86.
Yes, I got that too. But we can compare it and see if we have some.
And the score on that 6 is a 96.
But we need to run that.
I have 93.30 for the score on the 6.
I think that we must find that linear line.
So, but the other
Also.
6s in the confidence mean, and one is 93.3. And the other one was 94, or 96.7.
Oh.
So if
So we're looking for the predicted, not the actual score. We're looking for the predicted value.
So the predicted value.
So the predicted value is the equation, right?
Plugging in a 6 for the X, and then that's what it seems like.
18.69 plus 12.695 times 6.
What was the answer?
I got 94.86.
Which would be right in between them, so it makes sense. But
well, we can also plug it in and do here and put it in put a 6 here and then analyze it again.
Yeah, I can do that.
Let's see what that gives me. And that gave me a 94.859, which is 94.86. That's what I got.
So it's
and it rounded 3 decimals. So it's 94.860.
Yes.
Okay, 94.860. That's what I got.
Or do we put in 859?
I think both are correct. One is from the software, correct?
Yeah. Round 3 decimals, it says. I put both of my answers in from the software, so we'll see if those are correct. And if not.
Okay, I've got both answers on my notes. So.
Okay.
Okay,
so 13.
How many independent variables are present in the simple linear regression?
1.
I have no idea how to answer that.
Wait. Independent variables. Are we counting the 169 again? For the 139? Or are we just...
That's got to be written. That's got to be somewhere.
Oh, 1. It's got to be 1. More than 2? Oh, I don't know.
How many independent variables are present in a simple linear regression?
Independent is the X variable, correct?
I think it's just one because didn't he say next week we're learning when there's more?
Right. And if you go to the regression, the variables says 1.
Well, we shall see.
Okay. How many response dependent?
One is the question, is the answer?
Or
yeah,
number,
for both, right?
is a variable. But I don't know where you dependent variable.
I would think it's 1 too.
I would say 1 as well, because that's what it's telling me. Variables.
Variables. It's 1 for the dependent and 1 for the independent.
Okay.
Yeah.
Makes sense, but
In a simple linear regression.
Nothing makes sense. Are you kidding? I take that quiz and it's like I've never read the stuff before.
So 15.
Right. Okay. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and lengths of the major and minor axes. Meaning the company wants to predict the size of hat given the circumference. What is the response variable?
I think it's the size. Because the size is dependent on the circumference, right?
I've got it in my answers here somewhere.
Yes. The response is always dependable of something.
Okay, so then it should be the size.
The size is the Y.
Yes, the dependent variable or response variable.
But we have two for the size.
It's the first one because it's not predicting the circumference. The circumference is predicting the size.
The size of a hat.
Okay.
It's a variable being predicted.
Yeah.
So this, yeah.
So it should be number 1.
Okay.
Okay, so I will go ahead and
See what happens.
yes. Okay.
Although I have different answers, correct?
Yes, you do. So if I get it right, then you can maybe change your answers.
Unless they both are correct. Let's see.
Okay, so far question 7 is wrong.
7.
Oh.
It's simple linear.
Everything else is correct except for number 7.
Okay, so
it's not number 2.
okay, so then it would be number 1. Because it did make a pretty easy line.
Okay, now I'm gonna go plug everything back in.
Don't you think it's number 1?
Yeah, I guess. I don't know.
You have the right answer.
Because I think it could be really wrong or it could work. I don't know.
It looked pretty linear though.
Yeah, but did you see the number? It was only, well, it was like halfway. It was 0.5 something. So I don't know.
Okay, what numbers did you?
I don't know the conditions to answer these questions. So based on the shape. So based on the shape, and the shape that we got is like a
hot dog.
Hot dog. It's a positive. Positive, correct?
Yeah, I would say moderate.
Moderate, yes. So
I'll submit that number 1 and see what we get.
Okay.
Okay.
At least submit it again and get it right.
Yeah.
I think unless it's not with any shape. That we have a shape.
Okay,
that
it's
is-
number 1.
Okay.
It's number 1. Okay.
Yeah.
Let me see if my
Okay.
If your wrong answers work.
Yeah.
let's see if the calculator.
If only the homework quiz could be that simple.
Yes, they accept with both answers.
So yours was right too?
Was right.
Oh, good.
That's good to know.
Was right. Great. Done.
Yay.
Yoo-hoo.
Hey.
When I go to take the homework quiz, it's just not going to be easy.
I know it's going to be all
Mhm.
wonky.